So far, we've learned how to write systems of equations and how to solve them using three methods: graphing, substitution, and elimination. Now we get to pick which method we use most of the time. So today we're going to see one situation and we're going to solve it all three ways so you can see how this works for each way and you can make a choice for yourself later. So here's our situation. Sumaya and Travis are buying flowers for their garden. They want to spend only $20 at the garden center and know that roses cost $4 a plant and tulips cost $2 a plant. They want a total of 6 plants added to their garden. How many of each plant should they purchase? So the first thing we need to do is write our system of equations. The way that we did this when we were learning is that we defined our variables. So let's reread the word problem here and pick out the important things we know. We know that we are measuring roses and we are measuring tulips. So those are going to be the things that we don't know but that we want to figure out the number of. So we're going to let X represent the number of roses that Sumaya and Travis are going to purchase, and that Y be the number of tulips that Sumaya and Travis are purchasing. Some of the other things I know that they said roses cost $4 and tulips cost $2, and that we have a total of $20 and a total of 6 plants. Those are the important things I need to write this system of equations. So if I take the cost of the roses, which is 4 times every rose, and I add the cost of the tulips, which is 2 times every tulip, we should have a total of $20. See how I put all of the numbered or the dollar sign numbers together? We also know that if we wanted to total up or add up the number of roses and the number of tulips, that should equal 6 plants. Well, there we have it. That is our system of equations that we're going to use today to figure out this problem for Sumaya and Travis. We want to tell them how many tulips and how many roses they can purchase with this $20 so that they can get 6 plants. The first way that we learn to solve a system of equations is by graphing. Now, when we graph an equation, we need these equations to be written in y equals mx plus b form so that we have a slope and a y-intercept. Neither of our equations that we started with or that we wrote are written in that form. So we're going to have to solve both of them for y before we can graph this system. Here's the first equation that we wrote. If we start to solve this for y, we're going to take the 4x to the other side, cross the line, change the sign, write the whole problem down, and then we're going to divide by 2 everywhere in this equation, so that this equation now reads y equals negative 2x plus 10. If you'd like to write that as negative 2 over 1 so that you see the rise and the run, that might be helpful. This means that we're going to begin at 10 on the y-axis, and we're going to have a slope of down 2 to the right 1. Now you can do this more than once to find a really accurate slope, so I'm going to go down 2 over 1, down 2 over 1, until I feel like I can draw this by hand. Remember, when we graph with technology, we usually only need to put 2 lines, and then we can draw a super straight line, but when we're graphing by hand, you might need a little bit more help to get the line super duper straight. All right, halfway there, I have graphed the first equation. But if I take the second equation, x plus y equals 6, I need to solve it for y. I can do that in one quick, easy step. Move the x to the other side, we write down the equation, and now I only have y equals negative x plus 1. It might be helpful to remind yourself here that the slope is negative 1 over 1, and that the y-intercept is 6. So we plot a point at 6, and we find more coordinates by going down 1, right 1, down 1, right 1, down 1, right 1, until I feel like I can confidently draw a straight line in between those points with a straight edge. The straighter, the better. Now once I have both equations graphed, I am just looking for their point of intersection, the point where the lines cross. Since these two lines cross at one point, they are not parallel nor are they right on top of each other, we know that that coordinate point is 4, 2, which would be our solution. But since we're doing a real world problem, we need to answer back in real world. Since we said that X was the roses and Y was the tulips, what we know and what we can tell Sumaya and Travis is that they need to buy 4 roses and 2 tulip plants. That's what we know in real life. That's the solution here. 4, 2, which means 4 roses and 2 tulip plants. Great. So that's by graphing. That was one of the methods we learned to solve an equation. We also learned the by hand methods of substitution and elimination. We're going to solve by both for the same system. Okay, so we already know we should get 4, 2 because that's what we got when we graphed. Let's hop over to the inside. It says now let's solve the same system by substitution. Substitution, remember, is the method where we plug something in. But before we do that, we have to find an isolated equation. It would be easiest to isolate either one of the variables from the second equation, since they're both set equal or have a coefficient of 1. And just because we've already done this in the graphing problem, I'm going to take the second equation, I'm going to solve it for y. Cross a line, change the sign. And I now have the isolated version, y equals negative x plus 6. This is what I'm going to use as my isolated expression to plug in to the other equation. We're going to take the expression negative x plus 6 and we're going to plug it in for y in the first equation. Okay, so let's do that. We have 4x plus 2y equal to 20, but I'm going to replace or substitute that y for the expression we just found, negative x plus 6. Once I do the replacement step, or the substitution step, I have a single variable equation, which means I can solve like normal. We're going to start by distributing the coefficient of the parentheses so that I have 4x minus 2x plus 12 equal to 20. Don't let computation be the thing that messes you up. So if you need to grab a calculator on this part of the problem, please go ahead and do so. We set up our box method. If you would rather use inverse operations, please feel free to do that. We're going to drag and drop the terms to the box that they belong, but remembering when it crosses that center line, we have to change the sign. We add across the top, which means we're going to take 4x and add negative 2x, we'd get 2x, and negative 12 plus 20, we would get 8. Divide by 2 on both sides to isolate that x, and we'd find out that x is equal to 4. And we take a deep breath because we are halfway. We figured out what the x should be, but we need a coordinate pair. Luckily, we already have an isolated equation, the red equation, that is isolated for y, which means that I can plug in that value I've just found for x exactly right there. So I'm going to have y equal to negative x plus 6, but the x is 4. Then we compute. Negative 1 times 4 is negative 4, and negative 4 plus 6 is 2. Therefore, we know that our solution to this system is the coordinate pair 4, 2, which is exactly what we got when we graphed this system earlier. We know that Sumaya and Travis should buy 4 rose plants and 2 tulip plants. That's exactly what we found when we graphed it, which means we can choose our own method that we want to use. Both of them work. Let's check out the last method that we learned how to solve by. We learned how to solve by elimination. Now, elimination is the one where we need to have opposite like terms, or opposite terms between our standard form functions. Are there any opposite terms here? No, so this is one of the funky problems that we're going to have to manhandle a little bit and get to say opposite terms. I'm going to let the y's cancel out. So if I needed the y's to cancel out, this would need to say negative 2y, which means I need to multiply the whole equation here by a negative 2. Okay, so my new equation didn't change the top one at all, so I'm going to rewrite that down. But my new second equation would be negative 2 times x, that's negative 2x, negative 2 times y, that's negative 2y, and negative 2 times 6, which is negative 12. I've used a scalar multiple so that I can now see that I have like terms between the two equations, or opposite terms between the two equations, sorry. These opposite like terms right here are going to cancel out when I add these equations together. That's the elimination step. 20 plus negative 12, that is equal to 8. This would be 0, so they cross out. And then 4 plus negative 2x is 2x. We finish solving, and we would get that x is equal to 4. And we take a deep breath because we are halfway. But since we only have one of the two variables I need to go back to one of the beginning values, one of the original ones printed on the paper, and plug that in. It doesn't matter which one you choose, but remember, it would be easier to plug this value in wherever you see a coefficient of 1. And we have an equation here that has two coefficients of 1. So that's our indicator that that would be the easier equation to plug this back into. So I'm going to take x plus y equals 6, and I'm going to plug in that 4 exactly where it belongs, right here for the x. If 4 plus y is equal to 6, that means I'm going to take the 4 to the other side, cross a line, change the sign. That 6 minus 4 is going to give me my y value. Y would be equal to 2. Great. Since we have both the x and the y value, we can write it as a coordinate pair. Again, we'd have the coordinate pair 4, 2, which means 4 roses and 2 tulips as my x and my y. So it doesn't matter which method you choose as long as you pick a method that works. There are going to be problems that are set up that are going to be easier to graph. There are going to be problems that when you set them up are going to be easier to substitute. There are going to be problems that when you set them up are easier to use elimination. You can either figure out which one is easiest and use that method, or use the method you're most comfortable with all the time. You just have to make sure that you're following each of the steps correctly. See y'all in class.